Continuation of yesterday class, how to apply the formulas and how to use the steps by using rules. Similarly, differentiate the following with respect to x. 1 plus x squared tan inverse x. Let y equal to 1 plus x squared tan inverse x. Differentiating with respect to x. Y with respect to x divided by dx. Here bracket first function tan inverse x, second function. We are differentiating the product of two functions, so apply differentiation product. Differentiation of product rule is, if u is first function, p is second function, first function as it is, differentiate second function, plus second function as it is, differentiate first function. Same type, bracket first function tan inverse x, second function. First function as it is, differentiate second function, plus second function as it is, differentiate first function. We are differentiating by this product rule is also called like this product. Differentiation of tan inverse x is 1 by 1 plus x squared. Now differentiate 1 plus x squared. While differentiating 1 plus x squared, one differentiation 0, x squared differentiation 2x, so 1 plus x squared differentiation is 2x. Divide by dx equal to 1 plus x squared cancels. This is divided by this. Sin x cos x. Let y equal to sin x cos x. Differentiating with respect to x. Y with respect to another letter divided by dx. Again we are differentiating product of sin and cos. Use product rule. Sin x as it is, differentiate cos x, plus cos x as it is, differentiate sin x. Formula is differentiation of cos x minus sin x, and differentiation of sin x is cos x. First function as it is, differentiate cos. Differentiation of cos minus sin. Second function cos x as it is, differentiate first function sin x, it is cos x. Divide by dx equal to, second term is positive, first term is negative. This cos squared x minus sin squared x is multiple formula cos 2x. Cos 2x formula cos squared x minus sin squared x. X log x minus x. Let y equal to x log x minus x. Differentiating with respect to x. dy by dx equal to, according to rule, differentiate first term separate minus differentiate second term separate. First term is product. Differentiate first term, use product. X as it is, differentiate log x. Log x as it is, differentiate x. Differentiation of log x is formula 1 by x. Differentiation of x is first term is 1, second term minus. Differentiation of separate second term x is dy by dx equal to x cancels 1 plus log x minus 1, again 1 cancels, dy by dx equal to log x. Squared minus 4, 1 minus 2x. One method is remove the brackets, then differentiate. That is one method. Another method is directly we can differentiate with the help of product. Let y equal to x squared minus 4 into 1 minus 2x. Differentiating with respect to x. dy by dx equal to first bracket first function, second bracket second function, differentiate by product. First bracket as it is, differentiate second bracket, plus second bracket as it is, differentiate first bracket. Second bracket is 1 minus 2x. If you differentiate 1 minus 2x, it is minus 2. Differentiate x squared minus 4. If you differentiate x squared minus 4, it is 2x. This is differentiation of second bracket, differentiation of first bracket. Minus 2x squared plus 8 plus 2x minus 4x squared. dy by dx equal to 8 plus 2x minus 2x squared minus 4x squared. Or you multiply these two brackets, then differentiate, that is another. E power x cos x log x. Let y equal to e power x cos x log x. We are differentiating product of three functions. Differentiating with respect to x. dy by dx equal to, rule says while differentiating the product of three functions, second, third as it is, differentiate first. First, third as it is, differentiate second. Plus first, second as it is, differentiate third. In first term, first differentiation. In second term, second differentiation. In third term, third differentiation. Other than u, other than v, other than w. So directly we can differentiate by using this product. Second, third as it is, differentiate first. First, third as it is, differentiate second. First, second as it is, differentiate third. Differentiation of first is e power x. Differentiation of second is minus sin x. Differentiation of third is 1 by x. This is second, third as it is, differentiate first. First, third as it is, differentiate second. First, second as it is, differentiate third. These are the functions. dy by dx equal to, in all e power x common, cos x log x minus sin x log x plus 1 by x cos x. dy by dx equal to, in all three terms, e power x common. Again, in these two terms, log x common. Plus cos x by x. if y equal to e power log x by x, find dy by dx. Given y equal to e power log x by x, before differentiation base is not given, understood base is e. E power log x base e is nothing but x. I have seen in the last class. E power log base e of x is x. Cancels 1. Differentiating with respect to x. So dy by dx equal to 1 is constant, differentiation 0. If y equal to x squared minus 1 by log x, find dy by dx. Given y equal to x squared minus 1 by log x, differentiating with respect to x, dy by dx equal to, we are differentiating the quotient of two functions. While differentiating the quotient of two functions, rule is in denominator whole square. Denominator as it is, differentiate numerator, minus numerator as it is, differentiate denominator. Differentiate by this. In denominator, write denominator whole square. Denominator as it is, differentiate numerator, minus numerator as it is, differentiate denominator. Numerator is x squared minus 1. If you differentiate x squared minus 1, it is 2x. Because x squared differentiation 2x, 1 differentiation 0. Denominator is a log x. Differentiation of log x is a direct formula 1 by x. Dy by dx equal to, it is at 2x log x minus x squared minus 1 by x by log x shows. dy by dx equal to, in numerator LCM, in numerator x is LCM, 2x into x log x minus x squared minus 1, this is numerator LCM, whole divided by log x also. If fx equal to 1 minus x by 1 plus x squared, find 3 f dash 1 plus 5 f dash 2. Given fx equal to 1 minus x by 1 plus x squared, differentiating with respect to x, differentiation of fx, f dash x, this is nothing but dy by dx, this is nothing but y, this is nothing but dy by x, this is y, this is dy by x. Again, quotient differentiation, use quotient. Denominator whole square. Denominator as it is. Differentiate numerator. Minus numerator as it is. Differentiate denominator. Numerator is 1 minus x. 1 differentiation 0. X differentiation 1. Numerator differentiation minus 1. Denominator. Denominator is 1 plus x squared. If you differentiate 1 differentiation 0, x squared differentiation 2x, it is a 2x. This is the differentiation of NR, differentiation of dx. Question. F dash x equal to minus 1 minus x squared minus 2x plus 2x squared by 1 plus x squared whole square. F dash x equal to two x squared minus 1x squared minus 2x minus 1 by 1 plus x squared whole square. This is general dividends. Putting x equal to 1 and x equal to 2. Put x equal to 1. If you put x equal to 1, 1 squared minus 2 into 1 minus 1, x is 1, 1 squared is 1, 1 plus 1 squared. This is minus 2 by 2 whole square. It is minus 1 by 2. This is general dy by dx. This is particular dy by dx at x equal to 1. Now put x equal to 2. If you put x equal to 2 square, 2 into 2, 1, x is 2, 2 squared is 4. Here put x equal to 2 square, 2 into 2 minus 1, 2 square 4. F2 equal to, it is minus 1 by 25. 2 point. Problem is find 3 f dash 1 plus 5 f dash 2. F dash 1 is minus 1 by 2. F dash 2. F dash 2 is minus 1 by 25. This is nothing but dy by dx at x equal to 1. Sorry. This is nothing but dy by dx at x equal to, put f dash 1 minus 1 by 2, put f dash 2 minus 1 by 20. It is minus 3 by 2 minus 1 by 5. 10 LCM. It is minus 17 by 10. F dash 1 is nothing but dy by dx at x equal to 1. F dash 2 is nothing but dy by dx at x equal to 1. Only f dash x means dy by dx. If y equal to 1 minus cot x by 1 plus cot x, find f dash pi by given y equal to 1 minus cot x by 1 plus cot x, differentiating with respect to x, dy by dx equal to, again quotient differentiation by quotient, in denominator whole square, denominator as x, differentiate numerator, minus numerator as x, differentiate denominator. Numerator is 1 minus cot x, 1 differentiation 0, differentiation of cot x is minus cos x squared x. This is plus cos x squared x. Denominator 1 plus cot x. 1 differentiation 0. Differentiation of cot minus cosecant squared x. It is minus cos x squared x. Again, we have differentiated by quotient. dy by dx equal to cos x squared into 1 plus cos x squared into cot x. This minus plus cos x squared into 1 cos x squared into minus cot x. This minus into this minus plus cos x squared into 1 plus cos x squared into minus cot by 1 plus cot x whole square. This plus this minus cancels. Cos x squared x plus cos x squared x 2 cos x squared x by 1 plus cot x whole square. This is general dy by x. Now, particular dy by dx when x is pi by 4. dy by dx when x is pi by 4. X is pi by 4. X is pi by 4. Sin pi by 4 1 by root 2. Sin 45 1 by root 2. Cosec means reciprocal. Cosec pi by 4 is root. Tan pi by 4 is 1. If tan pi by 4 is 1, cot pi by 4 is 2. Root 2 whole squared is 2. It is 2 squared. 4 cancels. Answer is this is nothing but f dash pi by dy by dx at x equal to pi by 4 is same as f dash pi by 4 is find d by dx x plus 2 into sin x by x squared plus 1. Let y equal to bracket they are asking find differentiation with respect to x of this bracket. They are asking differentiation of bracket with respect to x. Therefore y is big bracket. Differentiating with respect to x, with respect to this x, dy by dx equal to, first it is quotient. Start differentiation by quotient. By quotient rule in denominator whole square. Denominator as it is, differentiate numerator minus numerator as it is, differentiate denominator. This is denominator whole square. Denominator, here we have to write numerator differentiation minus numerator, write denominator differentiation. Denominator is x squared plus 1, x squared differentiation to x, 1 differentiation 0, numerator differentiation to x. So, denominator differentiation. Here write differentiation of denominator to x. Numerator is x plus 2 into sin x product. X plus 2 first function, sin x second function. To differentiate numerator use product. Main differentiation by quotient rule. In quotient rule, while differentiating numerator, we have to use product. Quotient rule, product rule, together we are using in this problem. Main differentiation by quotient rule. While differentiating numerator is product. While differentiating numerator, we have to use product. In quotient rule, product. First as it is, differentiate second. Second as it is, differentiate first. Differentiation of sin cos. Differentiation of x plus 2. Differentiation of x plus 2 is, this is x plus 2 cos x plus sin x into 1. By differentiating numerator, bracket as it is, differentiate sin, plus sin as it is, differentiate bracket x plus 2. dy by dx equal to x squared plus 1 sin x plus x plus 2 cos x. This sin x into 1 plus x plus 2 into cos x. This is 2x, x plus 2 sin x. Divide by dx equal to x squared plus 1 sin x plus x plus 2 into cos x as it is minus 2x into x. Two x into and stop here. Cannot further simplify. Derivative of composite functions. This starts second year syllabus. Up till now we have seen first year revision, how to apply formulas, how to use the rules in steps. Now differentiation of composite functions. Let y be a function of not x e and in turn u be another function of x, then y is a function of a function of x called y is a composite function of x. First, direct y is not a function of x. First, y is a function of u. In turn, u be another function of x. Then y is called function of a function of x. That is called y is a composite function of x. The same thing in symbol. In symbol, let this is y is a function of u. And in turn, u is another function of x. The same thing we have done in symbol. First y is a function of u. Second u is another function of x. First function f1, second function f2. First y is a function of u. Second, u is another function of x. Now this y is called a composite function of x. This y is called a function of x. Called y is product of two functions. First y is in u, further same u in x. Now y is called function of x. Called y is a composite function of x. If x increment is delta x, corresponding u increment is delta u. First comes change in x, then comes a corresponding change in u. Let delta x be an increment in x, and let the corresponding increments in u and y be first x increment delta x, corresponding u increment delta u, then corresponding y increment delta. So these two are depending upon delta x. This is independent increment, these two dependent increments. If x changes, u changes. If u changes, y changes. And here y is product of two functions, or y is function of a function of x, called y is a composite function of x. First x changes, u changes. U changes, finally y changes. Delta u and delta y respectively. We have delta y by delta x can be written as separate delta y has a meaning, separate delta x has a meaning. We are introducing this delta u. Delta u cancels. If delta u cancels, it is delta y by delta x. It is an adjustment. This delta y by delta x can be written as delta u cancels. It is a delta y by delta x. Taking limit to both hand sides as delta x tends to 0. Limit of LHS when delta x approaches 0. Limit of RHS also when delta x approaches 0. RHS is delta y by delta u into delta u by delta x. Limit for left side, limit for right side with delta x tends to 0. as it is. This is product. Limit of product is product of units. Limit of first into limit of second. Limit of first into limit of second. As it is. As it is. Already we have written u is a function of x. Second function. First x changes, then u changes. Delta u depends upon delta x. If suppose delta x approaches 0, correspondingly delta u also approaches 0. If delta x approaches 0, correspondingly delta u also approaches 0. This is changing. When delta x approaches 0, delta u also approaches 0 as per this function. This is called increment. This is called increment in x. This is called increment in y. Separate increment in x, separate increment in y. This is incrementary ratio. For this incrementary ratio, limit is taken when denominator approaches 0. If suppose the limit exists, then it is called differentiation of y with respect to x. This is definition of differentiation. So limit of incrementary ratio is differentiation. Apply this definition. This is limit of incrementary ratio differentiation. This is also limit of incrementary ratio when denominator approaches 0 definition. Again, this is also limit of incrementary ratio. When denominator approaches 0, it is differentiation. This is dy by dx. This is dy by du. This is du by dx. Limit of incrementary ratio differentiation. Again, limit of incrementary ratio differentiation. Limit of incrementary ratio differentiation. Denominator delta x approaches 0. Denominator delta u approaches 0. Denominator delta x approaches 0. Which is known as sine of differentiation. Don't mistake, du cancels. If du cancels, it is dy by dx. It is not like that. Because separate du has no meaning. We cannot separate. We cannot separate dy and du. We cannot separate du and dx. Here we can separate. Here we can separate. Delta u cancels. It is delta y by delta x. But here it is not like that. Dy is not separate, du is not separate. It is not a du cancels, so that it is never dy by dx. Don't read like that. It is a child of what this rule says is. First, starting we have defined y is a function of u. Next, we have defined u is another function of x. Here, u. Then we can connect indirectly y and x. Using u, we can connect y and x. Here, y is not in x. Y is indirectly in terms of x. To connect y and x, we are using another letter u. This is first function, second function. So y is called function of a function of x. Function of a function means product of function is called composite function. So we can read y is a composite function of x. First, differentiate y with respect to u. You can differentiate y with respect to u. Here we can differentiate u with respect to right side vector x. Differentiate y with respect to u because right side is u. Here differentiate u with respect to x du by x. This dy by du first term and this du by dx second. So we are differentiating first term. From first term find dy by du. Differentiate second term. From second term get du by dx. Multiply dy by du and du by dx. That will become differentiation of composite function of y with respect to x. We can extend it for any number of terms. Similarly, if y is a function of u, u is another function of phi, and phi is another function of x. Here we have taken two functions, f1 and f2. Now we are extending, we are taking product of three functions. U connection, this PV connection, therefore we can connect y and x with the help of u and v. Y is a function of u, u is a function of v, v is a function of x. The same kind of will be like this. From first find dy by du. From second find du by dv. From third find dv by dx. From first find dy by du. From second find du by dv. From third find dv by dx. Again du sign, dv sign. It is called sign rule because sign of du, sign of dv, so that it is dy by dx. Again, du never cancels, dv never cancels. The same sine rule we have extended for one more function. Similarly, if y is a function of u is a function of v, and p is a function of x. Here, y is a function of a function of a function. Three functions. Y is a function of a function of a function of x. So y is called a composite function of x. Here y is called a composite function of x. Because just like in the last class, we can't directly find a dy by dx. There. dy by dx equal to dy by du, du by dv into dv by dx. This is also same. Is also the same sign. Oh, there. Yeah, du sign, dv sign, therefore it will become dv. For example, let y equal to root of x squared plus bx plus c be the composite function. Here, let y equal to root. Y is a root function where u means ax squared plus bx plus here y we have expressed in terms of u. Further u we have expressed in terms of x. Other than y, u and x remaining are all constants. These UVC are constants. We have splitted this composite function. We have done two functions. Y is a function of u. Here u is a function of x. Differentiating with respect to right side letter u. Here differentiating with respect to right side letter x. Y with respect to u. Formula is differentiation of root x is 1 by 2 root x. For same type, differentiation of root u, same type, differentiation of root u is 1 by 2 root u. Same, change letter. Here x, here u. Differentiation of root u is 1 by 2 root u. U means ax squared plus bx plus put u there. Here differentiate u with respect to x. A constant according to Ku function, keep constant as it is, differentiate constant. In second term, b constant, differentiation of x squared is 2x. Differentiation of x is 1. Differentiation of constant c. It is individual constant, differentiation of constant 0. A constant, differentiate x squared. B constant, differentiate x. Differentiation of constant c is 0. Du by dx equal to, it is 2ax plus by sine rule. Dy by dx equal to dy by du into du by dx. Dy by du is first equation. Dy by du first equation. And du by dx second equation. From 1 and 2. Therefore, dy by dx equal to, it is 2ax plus b by 2 root of ax squared plus bx plus we are not writing this type in an lengthy way. Just it is a sample shown how sine rule comes, how we can express the given function as the product of two functions. Actually, in routine work, from y, directly we are writing this type. Not necessary to write all these things detail. Wherever composite function comes, you have to differentiate only by sine. If I say composite function, no doubt sine rule comes. Thank you.